So let's start with some one-dimensional motion problems. So first question. In Hawaii's 1999 Ironman triathlon, the winning athlete swam 3.9 kilometers, biked 180.2, and then ran 42.2, all in 8 hours, 17 minutes, and 17 seconds. Determine the winner's average speed in kilometers per hour and also in meters per second. So first of all, what do we want? So our unknown. Okay, we want velocity, average, in kilometers per hour and meters per second. What do we know? Well, we know his distance is equal to 3.9 plus 180.2, excuse me, plus 42.2. So that equals 226.3 kilometers. Time, we also know, let's find the time in hours, because that's what one of the first questions is asking for. So we have 8 hours plus 17 over 60, because there's 17 minutes in this particular hour, plus 17 over 3600. 3600 because 60 seconds in a minute times 60 minutes in an hour gives you 3600. You put that in your calculator, and you get 8.29 hours. So let's find velocity, average, distance over time, which is 226.3 kilometers over 8.29 hours. And we get 27.3 kilometers per hour. Now the second part of the question asks for it in meters per second. So let's convert our 27.3 kilometers per hour into meters per second. So how do we do that? Well, first of all, let's get rid of the hours. So we'll put 1 hour up here, and we'll do 3600 seconds. And now we'll get rid of the kilometers. 1 kilometer down here. 1,000 meters in a kilometer. And when we do that, we end up having 27.3 times 1,000 meters divided by 3,600 seconds. And we get 7.58 meters per second. There's one answer, and there's the other answer. Next question. Calculate how far light can travel in a vacuum in 1 second. B, 1 millisecond if the speed of light is 3.0 times 10 to the 8 meters per second. Sorry, that should obviously be 10 to the 8 meters per second. Okay, so how far do we, what do we do here? Well, first of all, it's asking for how far does light travel. So distance is our question. Okay, we know velocity, it's 3.0 times 10 to the 8 meters per second. And if we're looking at A, we know time as 1.0 seconds. So our equation, V equals D over T, can be rearranged so that T equals D over V. So let's use that. So A, T equals D over V. Excuse me, we're looking for D. D equals T times V. Sorry about that. T is 1. Velocity is 3.0 times 10 to the 8. And therefore we get 3.0 times 10 to the 8 meters. B, still looking for distance. Velocity is still 3.0 times 10 to the 8 meters per second. But now our time is going to be 1.0 times 10 to the negative 3 seconds. because that equals 1 millisecond. Okay, so we use our same equation. Distance equals t times v, which is going to equal to 1.0 times 10 to the negative 3 seconds times 3.0 times 10 to the 8 meters per second. The seconds cross off, and we're left with 1 times 10 to the negative 3 times 3 times 10 to the 8. And that equals to 3,000,000, which is also equal to 3.0 times 10 to the 345 meters. So our next question is, estimate in days how long it would take you to walk non-stop at your average walking speed from one mainland coast of Canada to the other. The human walking speed, so V, is 5 kilometers per hour, and the distance is going to be approximately 7,250 kilometers. Now the question asks for in days, so let's convert our velocity into kilometers per day. Okay, so 5 kilometers per hour times 1 hour, 24 hours in one day gives us 5 times 24, gives us approximately 120 kilometers per day. Now, I wouldn't say that that is reasonable. Let's just say that we're walking for 12 of the 24 hours in a day. So let's multiply that by 1 over 2. And what we come up with is approximately 60 kilometers per day that you could walk for if you were going at this pace. So we have our equation, V equals D over T. Okay, T is the question in days. T is going to equal to D divided by V. Distance is 7,250 kilometers. Velocity is 60 kilometers per day. The kilometers cross out, and we get 7,250 divided by 60, which is equal to 120.8 days. Now, if you want to be even more correct, 0.8 days times 24 hours per day gives you about 19.2 hours. So really you're looking at 120 days and about 19 hours. What scalar quantities are measured by our car's odometer and speedometer? Well, an odometer is going to measure your distance. Okay, and a speedometer is going to measure your speed. Like you're moving, for instance, 100 kilometers per hour or 60 miles per hour. State what each of the following represents. Well, the slope of a line on a position time graph. So in this case, the slope right here, anytime we're looking for slope, we're looking for rise over run, or y2 minus y1 over x2 minus x1. Okay? But if we want to look at it slightly differently, If you want to look at the rise, rise is position. So, for instance, meters. And the run is time, or seconds. So the units we end up with is meters per second, which in this case is going to represent our velocity. B says the area under the line on a velocity time graph. And if we look at it in a similar way, okay, the area, so let's just take a look at this shaded area right here. Anytime we're looking at area, we're looking at area equals length times width. And let's just say that that's length, and down here is width. Okay. Now length in this case is going to be represented by meters per second because it's velocity. The width is going to be represented by time, or in this case seconds. So when we do this, seconds cross off and you're left with meters. Therefore, the area under a line on a velocity time graph is going to represent your distance. What is the relationship between the magnitude of the slope of the line on a position time graph and the magnitude of the velocity of the motion? Well, they're actually going to be equal to each other, and we'll see that. Okay, let's take a look at the slope of our dt graph. Okay, the one on the left, right here. So if we look at rise over run, and let's take that point and that point because it's easy. So we'll say we have a rise of about 1,000 minus 0 over 180 minus 0, which is of course just simply 1,000 over 180. If you put that in your calculator, you get 5.56. And when we look at our velocity time graph, you'll notice that's the same. So the question says, what is the relationship between the magnitude of the slope and the position of the velocity of the motion? We would say that they are equal. To prove that ancient mariners could have crossed the oceans in a small craft, in 1947, a Norwegian explorer named Thor Heyerdahl and his crew of 5 sailed a wooden raft named the Kon-Tiki westward from South America across the Pacific Ocean to Polynesia at an average velocity of 3.3 kilometers per hour west. How long did this journey of 8 times 10 to the, again, my apologies, that should be 10 to the 3 kilometers west take? Express your answer in hours and days. So, how long did it take? Well, that's time. Okay. We know that the velocity was 3.30 kilometers per hour west. We know that the distance was 8.0 times 10 to the 3 kilometers. So, not too bad. Let's find v equals d over t. We rearrange once again, and we get t is equal to d over v. We get 8.0 times 10 to the 3 kilometers divided by 3.30 kilometers per hour. Kilometers cross out. You're left with 8 times 10 to the 3 divided by 3.3, which is equal to 2424.2 hours. Okay, so that's the first part of the question. So now, if we have 424.2 hours, and we divide that by 24 hours per day, the hours cross off, and we are left with 101.0 days. So our answer, 101 days and 2,424.2 hours. Now, we should actually put this into proper scientific notation and proper sig digs. We have 3 sig digs there, 3 sig digs there. Therefore, let's put our answers into sig digs. So we have 2.42 times 10 to the 3 hours. And, well, that one actually is all right. 101 days. Determine the time to complete a hurdle race in which the displacement is 110 meters forward and the average velocity is 8.5 meters per second forward. So we're looking for the time. We have a displacement of 110.0 meters forward, and the velocity is 8.50 meters per second forward. Very straightforward question here. Again, V equals D over T. We can rearrange to get T is equal to D over V. D is 110.0 meters. V is 8.50 meters per second. The meters cross off, and we're left with 110 divided by 8.5, which is 12.94 seconds. Now, proper sig digs would dictate that we have 3 sig digs in 8.5, 4 in 110.0, therefore we must end up with 3. Therefore, our answer should be 1.29 times 10 seconds, or simply 12.9 seconds. To maintain a safe driving distance between 2 vehicles, the 2-second rule for cars and single motorcycles is altered for motorcycle group riding, as in more motorcycles riding than just one together, as shown below. So as shown right there. The leading rider is moving along the left side of the lane and is 2 seconds ahead of the third rider. So that's the lead rider. That is the third rider right there. At the uniform velocity of 90.0 kilometers per hour east. So what is the position of the second rider relative to the leading rider? So let's write down what we have first. So we know time is 2 seconds. Okay, we were told that. We know that the velocity is 90.0 kilometers per hour. So now it doesn't dictate what kind of units we need to use. So let's just say, let's put this into hours. Seems the easiest thing to do. 2 seconds. Okay, we take 2. We're going to divide that by 3,600 because there's 3,600 seconds in a minute. And we are left with 0.00056 hours. Okay. You know what? We could also do it a different way. Maybe it's easier to do it this way. We're going to take 90 kilometers per hour and let's change it to meters per second. That seems to be a smarter way, actually. So 1 hour, 3,600 seconds, 1 kilometer, 1,000 meters. Okay, the kilometers cross off, the hours cross off, and we're left with 90 times 1,000 divided by 3,600, which gives us 25 meters per second. Let's use that. That seems to be better. Okay, so now the question is asking for what is the position? So really the question is saying what is D? How far is the third rider from the first rider? So we know our equation, hopefully by now. V equals D over T. Rearrange D equals V times T. V is 25 meters per second. Time is 2 seconds. Seconds cross off, and we are left with 50 meters. Now, What is the position relative to the first? Well, since the riders are going east, we would say that the second rider is 50 meters west of the first rider. So the third rider is 50 meters west of the first rider.